A particle has an initial position vector of that. If the particle moves with a constant velocity of that is 2I minus 4j meters per second, that is supposed to be meters per second, find the position vector after 1 second and after 2 seconds. So we get working. Now remember here that the formula is simple, that a particle, it has an initial position vector of 5. Now let's assume that let the particle be y. So now if the particle is y, if we are to find the general expression for the position vector of a particle after a certain time t, we know that the position vector which we are denoting as r, position vector after a certain time t, will be given by the position vector of y plus time times the vector, the velocity vector of that. This is how we denote it. Oy is the position vector, and here this is velocity vector times time. This is speed times time. Speed times time means that you are adding a certain distance, because distance is equal to speed times time. So it means that you're adding this distance that this particle has traveled with this vector, you're adding this distance on top of the distance from the origin, which is the position vector, so that when you add those two, you're able to get the position vector after a certain time t. So in this case, the position vector Oy, according to our question, it is 5I plus 3j. We can write this in column form. This is I 5, 3 plus time times the velocity vector. Now the constant velocity that this thing is traveling is 2 and negative 4. So this becomes 5, 3 plus t. This is now the general expression, plus t into 2 negative 4. That is this is the position vector after a certain time t. T can be anything. But now this question is telling us that find the position vector after 1 second. So meaning to find this position vector after 1 second means that we're simply going to substitute the value of 1 here. Then part B, after 2 seconds, it means we're going to substitute the value of 2 here, and we shall be getting our respective answers. So in this case, to answer part A means that we are going to find, it's going to be r times, after 1 second means the value of t is 1, r of 1 is going to be 5, 3 plus the value of t is 1 into 2 negative 4. Of course, 1 times 2 is 2, 1 times negative 4 is negative 4, so this remains the way it is. It becomes 5, 3 plus 2 negative 4, like that. So we go ahead and add these vectors. When we add these vectors, it's going to become 5 plus 2, which is 7, then 3 minus 4, which is giving us negative 1. Now this is in the x direction, this is in the y direction. So finally, the position vector, the question wants to find the position vector, remember? So it means that the position vector, which is r of 1, is going to be 7I minus 1j minus j. And this is in meters. So this is the position vector of that particle after 1 second. So now to find the position vector after 2 seconds, we are still going to substitute the value of t. We're just going to put there number 2. So meaning after 2 seconds, meaning that when r is 2 seconds, it's going to be equal to 5, 3. Add that to 2 into 2 negative 4. This gives us 5, 3 plus 2 times 2 is 4, and then 2 times negative 4 is negative 8. Then you will end up with 5 plus 4 is 9, so this is going to give us 9. Then 3 plus negative 8, this is the same as saying 3 minus 8, because this positive and negative is the negative that takes the day. So 3 plus negative 8 is going to simply give us negative 5. So when we do, so this becomes our position vector after 2 seconds is going to become 9I. This is in the x direction, then the y direction is minus 5j. So here we have converted the vector from column form to ij notation. We convert this to ij notation because the question the vectors given in the question are in ig notation, so it means that our answers have to be in ig notation. We have another number here. A particle has an initial position vector of that. So now let's call that particle P. So if that's the particle is P, it means that its position vector, a particle has an initial position vector of this. So it means that the initial position vector of P is going to be equal to A, B, C, K. So I like writing these in column form. It's easier to calculate them when they're in column form. Then we shall give the final answer in IJ format. So this is going to be A, B, C. That's the vector, the position vector of P, or P. Then they're telling us that the particle moves with a constant velocity of this. So it means that the velocity vector it moves with is 3, 1, and 4 meters per second. And after 2 seconds, it has a position vector of that. So it means that after 2 seconds, this is its position vector. So meaning that its position vector after 2 seconds is going to be equal to 7, 1, and 4. Like that. So we're supposed to find the values of A, B, C and find how far the particle is from the origin after 2 seconds. So at first, our first task is to find the A, B, C, the values of A, B, and C. Now again, we know that the general expression to find the position vector of a particle after any time t means that the position vector after a certain time t is going to give us first the position vector of this, which is going to be OP plus the added distance it travels from the position vector, and of course the added distance it traveled is going to be speed times time, which is going to be the velocity vector, multiply that by the time. And in this case, r of t, the position vector after any time t is going to be OP. Our position vector here is A, B, C plus time times the velocity vector, which is 3, 1, 4. So this is the general expression for our position vector after any time t. But now the question wants us to find the values of A, B, C. Now, since we have that the position vector after 2 seconds is 7, 1, 4, so we are going to take advantage of this information to help us find the values of A, B, and C. So R of 2, it means that when the value of t is 2, when we put 2 here, it means that this whole expression will be equal to 7, 1, 4. So we know that meaning that when our value of t is 2, the expression is that. So meaning that r of 2 is going to be 7, 1, 4. So we substitute here when the value of t is 2, it means that the position vector is 7, 1, 4. So meaning that here 7, 1, 4 is going to be equal to ABC plus t. Our value of t is 2 times 3, 1, 4. And of course now this is going to become 7, 1, 4 is going to give us A, B, C plus 2 times 3 is 6, 2 times 1 is 2, 2 times 4 is 8. For us to be able to find ABC, we are going to make this the subject of the formula, so this comes that way. So this becomes 7, 1, 4 minus 6, 2, 8 is going to give us A, B, C. So our value of A here is going to be 7 minus 6, which is 1. We have 1 minus 2, which is negative 1. Then we have 4 minus 8, which is negative 4. So from here we shall conclude by saying that our value of A is actually 1. Our value of B is negative 1. Our value of C is negative 4. And that's how we get our values of A, B, and C. So after finding the values of A, B, and C, now we're being asked to find how far the particle is from the origin after 2 seconds. Now to find they're actually asking us to find the magnitude of the vector, because as far as the particle is from 2 seconds, according to the question, they're telling us that after 2 seconds, it has a position vector of this. So meaning that after 2 seconds, the position vector of the particle is 7, 1. That's the position vector after 2 seconds. So it means that if we are to find the distance this particle is from the origin after 2 seconds, it means we are supposed to find the magnitude of this vector. So it means that the magnitude of vector is going to give us, we're going to simply find the square root of 7 squared plus 1 squared plus 4 squared. That's going to give us, under the square root, 7 squared is 49 plus 1 plus 16. And we shall end up with, so meaning that this is going to give us 8.12 meters. And so that's the position of the particle. And this is how far the particle is from the origin after 2 seconds. You can try out the number on the screen. A particle has an initial position vector of that meters, and the particle moves with the constant velocity of this. Find the position vector of the particle after t. Then afterwards, the position vector of the particle after 5 seconds. Now for this kind of answer, for this kind of number, I expect that when you do part A, you will get an expression which, such that when you put number 5 as the value of t, you should be able to get 19i minus 7j minus 16k as your final answer. This brings us to the end of this video. Thanks for watching. Feel free to check out other excellent videos on the channel, and don't forget to subscribe. For Kisembo Academy, this is Arnold.